Welcome back, friends, to this brand new Techhandy course on VMware vSphere 7. If you're interested in VMware virtualization, you're in the right place. Before we begin, make sure to hit that like button, share your feedback in the comments, and subscribe so you don't miss the next part of this VMware vSphere 7 lab series. In today's video, we're going to talk about one of the most powerful features of vSphere, Auto Deploy. We'll learn what Auto Deploy is, why it's important, and how it helps automate ESXi host deployments in enterprise environments. Auto Deploy is a VMware feature that allows you to provision ESXi hosts over the network, without manually installing the hypervisor on each server. It uses PXE boot and a deployment rule engine to load ESXi images directly into memory, based on host attributes or rules you define. This means you can deploy, update, and manage large numbers of ESXi hosts quickly and consistently. In short, no USBs, no manual installs, just network-based provisioning. That's why Auto Deploy is extremely useful in large-scale enterprise environments. We'll also cover the following topics in this video. How to enable Auto Deploy and Image Builder. How to download and import the ESXi depot from Broadcom for Enterprise Plus. How to create a deploy rule. We'll then prepare an ESXi machine in VMware Workstation for Auto Deploy. We'll configure DHCP reservations and DNS entries for that ESXi host. Then we will set up DHCP scope options for PXE boot. Next we'll install Windows Deployment Services, WDS, and configure TFTP. Next, we'll edit the registry for WDS TFTP read filter. Finally, we'll boot the VM from VMware Workstation to see Auto Deploy in action, and we'll verify it inside vSphere. We have a lot to cover, so let's get started. Before we dive into lab, I would like to describe the components and architecture of an Auto Deploy. First one is the image state. Image state is the operating system that runs in an ESXi host. Different vendors have their own ESXi host images, and you can download those from VMware Broadcom website. You can download those from the specific vendor's websites, for example, Dell or HPE. You can even build your own images, your own custom images for your own specific hardware that's going to run ESXi. Next is the configuration state, which is the configurable settings on the ESXi host. Those can be created with Host Profile GUI. You could go without it and you could manually configure the host, but the whole point of this is to deploy an image and a configuration. Dynamic state is the runtime state that's generated by the operating system, which means you boot up this brand new ESXi host that you have deployed, and the configuration state of that host, as it's dynamically been generated, makes up the dynamic state. That's stored in the host memory and it's created just during regular operations, and it's lost after reboot because these hosts are booting up their operating system over the network every time they boot by default. That's the default configuration. There are other ways to configure Auto Deploy where that operating system is booted up and then stored locally so that configurations wouldn't be lost and so that the operating system wouldn't have to be booted up every time. But, by default, the dynamic state is to boot up or stream that OS over the network, and because of that any configurations you make are simply stored in memory. You have virtual machines that you bring up on that host, and their state is stored in VMware vCenter. Those virtual machines are likely going to be stored on a SAN, or a NAS, or VMware vSAN, so their state will be stored along with the storage for each virtual machine. User input is the unique configuration that cannot be contained within a host profile. These have to be created from the host customization or answer files, and you are prompted for this type of data when you create a host profile. Auto Deploy has a few different modes that you need to be aware of. Under the default operation, the host doesn't store the image. When the ESXi host requests the image, it downloads it or streams it to the host, but it doesn't install that image or store that image on disk. On subsequent boots, that host boots again from Auto Deploy, and it will re-download the image again. This doesn't take very long, and it works quite well. But keep in mind, every time your hosts boot in the default operation mode, they have to pull their image from the Auto Deploy infrastructure. So, if that doesn't work, if some piece of it is down and there are multiple pieces that make up the Auto Deploy puzzle, then your host will not boot. And if you have 1 host, 10 hosts, or 100 or 1000 hosts, those hosts will not boot up without all the pieces of the Auto Deploy infrastructure working at 100%. If the auto-deploy infrastructure is being used every time host boot, then you may need to put in some sort of high availability layer on top of it to ensure that the auto-deploy infrastructure is always available. Another option is called a stateful image. This is where the host stores the image on the host once it boots. That way on subsequent boots, the host boots from the stored image. Auto-deploy infrastructure is only required during the initial deployment. Third available option is called stateless caching. The host stores the image, just like with the stateful option. But on the subsequent boots, the host boots from the stored image if it's unable to access auto-deploy. So it tries to boot from auto-deploy. If it cannot, then it uses the local image. That way the auto-deploy infrastructure is only required to complete the configuration of the host. Let's discuss vSphere auto-deploy requirements. First one is working DNS. Needs to be forward and reverse host entries for all your hosts, as well as the vCenter server. Next is auto-deploy enabled on the vCenter server. TFTP and DHCP server could all be on the DNS server. For example, using Windows Server. Image for deployment is the image that you're going to deploy. That image could be pulled down from the VMware Online Image Depot. Or it could be pulled down from the ESXi Offline Bundle, which is a zip file that you download and use locally. Last but not least, the ESXi host configured for PXE boot. The boot order is not set to only boot off of the local hard drive or a CD/DVD drive only, then those hosts are never going to request a DHCP IP address and perform the network boot. Enough theory, now let's jump to our lab. Let's start by enabling auto-deploy and image builder services in vCenter. Both are disabled by default. Go to Menu and click on Auto-Deploy option to enable the Auto-Deploy and Image Builder services. These services are required for managing ESXi image depots and building deployment rules. You can also manage these services under vCenter Server Management. Let's enable the services and change the startup type from manual to automatic, so they will auto-start and keep running in case vCenter server reboot for maintenance or for any other reason. Log into your Broadcom VMware account and download the ESXi7 Offline Depot zip for Enterprise Plus. An ESXi Offline Depot is a package repository, .zip file, that contains VMware ESXi installation or update files, including vSphere installation bundles, metadata, and image profiles, all bundled so you can install or update ESXi without internet access. Once you log in, go to My Downloads section and look for Depot under Free Software Downloads. Since our lab is using ESXi7 and vSphere 7 Enterprise Plus licensing, we'll use that version. Look for version you are looking to deploy and download it accordingly. Once download complete, copy downloaded.zip folder to the machine from where you are managing your vSphere. In our case, it's our domain controller server. Once done, return to vCenter client. Under Auto Deploy Software Depots, click on Import. Provide any meaningful name and browse to import the same offline depot zip folder. This will make the ESXi image available for building rules and deployment. Wait for the package to load. Once done, you will able to see two profiles, one standard including tools and other without tools. The standard ESXi image profile includes VMware tools packages, while the no tools profile excludes them to create a smaller image for automated or minimal installations. Now we'll create a deploy rule that defines how auto deploy provisions hosts. Go to Auto Deploy Rules and click on New Deploy Rule and give it a name. Then select the hosts with specific pattern. The pattern in a vSphere auto deploy rule specifies which ESXi hosts the rule applies to, based on matching attributes like MAC address, IP range, or vendor. For this lab, I will define IPv4 range from our predefined DHCP scope address pool, and then later we'll create the reservation for the new ESXi host under the same range. The pattern will look for any new device comes online under IP range 145 to 150 as we defined. Those will be the only IP addresses that will receive this image and configuration if we add any. Select Image Profile. We'll cover host profiles in the next video. Select the standard ESXi image profile that includes VMware tools packages. Review and click Finish. Wait for the rule creation. Our is now created, but it's inactive currently. Let's activate our created rule. Next, let's prepare a new virtual machine in VMware Workstation Pro, which will simulate our physical ESXi host for auto deploy. We'll name it Node 05. Assign reasonable resources, for example, 4 virtual CPUs, 8 GB RAM, and a 50 GB disk, just to simulate PXE boot. Make sure to keep network same as your domain DHCP, so it can locate DNS and get IP accordingly. Before powering on this VM, open its settings and note down the MAC address of the NIC. We'll use this MAC address for DHCP reservation and DNS configuration. Generate the MAC address and copy it since it's new VM and not powered on yet. On our Windows Server Domain Controller, DC01, open DHCP Manager. Under your scope, right-click on Reservations and add New Reservation for Node 05. Make sure to create reservation from the IP range that we defined under Deploy rule earlier. Paste the copied MAC address of new ESXi node. Our reservation is now ready for our auto-deploy ESXi node. Next, open your scope configuration options. Add the following options. Look for option 66, boot server host name. This will be your WDS or TFTP server IP, which in our case is same DC01 domain controller IP. Then for option 67 boot file name, enter file name accordingly for BIOS boot or UEFI boot file name. These options tell the host where to find the boot image when it starts. We'll also show these actual files later in this video. For this lab we are using BIOS boot file name. Next, open DNS Manager and create a forward lookup zone entry and a reverse lookup entry for the same Node 05 hostname. This ensures that PXE boot and vCenter integration work properly. Next, we'll install the Windows Deployment Services role. In this lab, we'll use our domain controller for simplicity, but in production, WDS should be on a dedicated server. Open Server Manager, add roles and features, then select Windows Deployment Services. Follow the screen and install it with default options. Once installed, open the WDS Management Console and configure it by following screen instructions. Specify the remote install directory. Default path is C:\remote install. We'll disable IPv6, since we are not using IPv6 in this lab environment. I will select PXE server to respond to all client. In real production environment, follow your company policies. Before you enable and start WDS, make sure to verify some of the following WDS properties again. In our lab, we enable PXE respond to all client computers. Make sure to change the boot configuration, continue the PXE boot unless the user presses the escape key option checked. And most importantly, since our DHCP and TFTP is on same server, but we are not using any boot file through WDS, uncheck configure DHCP options to indicate that this is also a PXE server. Ignore if you got the system cannot find the file specified warning. We are now ready to start the WDS service. Under Auto Connect, click on Configure and download a TFTP zip folder containing VMware Auto Deploy boot files. Once download, extract zip folder and copy all contents to the C:\remote install folder used by WDS. If you notice, here are those two BIOS and UEFI boot files that we discussed earlier, and enter under our DHCP scope option. Your ESXi hosts have to request PXE network boot. If they are not configured to request PXE network boot, they are never going to request boot, and they are just going to fail to boot unless they have some other local option to boot ESXi. For our lab, we are using Windows WDS Server TFTP, but there are so many great free TFTP server options available as well. For WDS TFTP, you need to do additional registry settings to make it work. Open Registry Editor and navigate to following WDS TFTP path. Modify the read filter string value and add \* at the end. You can ignore the warning and verify the change applied. Now go back to VMware Workstation, edit your VM settings, and change the boot mode to BIOS. You can also use UEFI, but make sure to update the boot file name accordingly under DHCP scope. Once all set, power on the VM, and you should see it attempt a PXE boot. It will contact the DHCP server, download the image from WDS, and then auto deploy will start provisioning ESXi automatically. As you can see, new ESXi picked the assigned 145 IP from our domain DHCP. ESXi deployment process is now started successfully. Wait for it to complete the deployment. Our new ESXi host is now installed, but it does not have any configuration. That will be done with a host profile, which we will see in next video. After the process completes, open your vSphere client and verify that the new host appears under Auto Deploy Deployed Hosts tab. So that's how you configure VMware Auto Deploy end-to-end, from enabling services and configuring DHCP, DNS, WDS, and TFTP, to watching your ESXi host deploy automatically. In the next video, we'll cover host profiles. If you found this video helpful, please like, subscribe, and share it with others who want to learn vSphere automation. Thanks for watching Techhandy. See you in the next one.